got you! Ha 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 ha! That wasn't rehearsed. Hello everybody, something a little bit different for you this week, because I've just finished a job which I completely forgot to make any note of or record or photograph in any way, so I can't tell you what it was, other than it was a very rare and expensive and scarce cylinder head off an old motorbike. I get all these off-piste jobs, all the things that people say can't be welded or people are frightened to touch in case they break it, and it's a throwback to the Bluebird thing when we mended stuff that people said couldn't be mended. So anyway, this chap brings his cylinder head in, can you fix it? And it was just a kind of that shaped flange with two bolt holes with a carburettor went on, I think. One lug was off and a thread was tied in the other one. So can you weld it? Yes, no problem. Welded it up, faced it off. And the other job that I always get is to restore the surface finish so it looks like it hasn't been mended. So I did all the artistry on there, put the cast line back and the patina. And for belt and braces for good measure, I helicoiled his threads. So I rang the fella up, come and get your job because I've got to pay for Christmas presents somehow. And he turned up to get his job and I said, look, it's welded. And he went, oh, very lovely, yes, marvellous. And I said, and I've helicoiled your threads, just for belt and braces. And he looked all crestfallen. And he went, oh, well, why have you done that? I said, well, to make sure it's a proper job. And he went, no, I'd much rather it had the real threads like it's supposed to. And I said, yeah, but this is better. And he went, oh, no, it isn't. I've seen it. He basically said it was a bodge without using that word. And I said, well, it really isn't. You know, I'll tell you what we'll do. We'll have a cup of tea and I'll show you why I think it's better. And if you still think it's worse, I'll take them out and I'll do it again for you. So we had a cup of tea and I did a couple of sketches, which I'll show you in a second. And then I devised a devious experiment after he'd gone to prove to me whether putting helicoils in, well, I know it's stronger. We did it so many times. We did it on Bluebird where we had outer skins on the sponsons that were 2 mil thick. You could tap them and put a 2BA screw in and they'd strip if you went too far. You could tap them and helicoil them with a little 2 mil thick helicoil and you'd wreck the screw head before you ever damaged the thread. But anyway, I wanted to know or see this demonstrated, so I decided to put bolts into chocolate. And I did an experiment which you can have a look at in a couple of minutes. But I explained to this chap that helicoils are not a bodge. They are a genuine engineering solution to a genuine engineering problem. And when I say helicoils, that is a kind of proprietary name for thread inserts, much in the way that Henry is a proprietary name for a vacuum cleaner. Technically they're thread inserts, but I'm going to call them helicoils, or helicoils if you want to be exact. And they were designed in the late 30s, early 40s when aircraft manufacturers were building bigger and bigger planes, and they wanted bigger and bigger engines, which became heavier and heavier engines, and they're massive assemblages of moving parts that are very maintenance hungry, and they're taken apart and put together, and they started using magnesium and magnesium alloys. And part of the problem was that you put threads into stuff like that. If it doesn't strip when you're taking the thing apart and putting it together, the threads wear very quickly, and on aircraft engines they tend to be fine threads anyway for the clamping force you get on them, so they'll not take a lot of abuse before they get very tired. So thread inserts were designed for the aviation industry by the aircraft engine manufacturers. And a little aside, little gem of information for you, helicoils were specified on every single space shuttle. Everyone had helicoils in it. That's another story. So I'll show you why helicoils were needed in the first place, because you might not have seen this, and I'll show you what a helicoil is and how it works, because you might not have seen that either. So this is why you need them. This is a little sketch I did for the cylinder head man, and if you just drill and tap a hole into the native material and then you put a bolt in it, which will typically have a washer, and then there's the thing you're bolting on, your inlet manifold, whatever it may be, and a gasket. This thread here in the native material is protected by the one above. And that one is protected by the one above, and that's protected by the one above, and so it goes until you get to here where there isn't a thread above. And the result of this is that any bolt fixing into something like this, and the softer the material, the worse this becomes, 60, 70, 80% of the load on the thread is shared between the top two threads. Which means if you keep winding, you're just going to screw this piece of material here out of the top of the hole, which makes the next thread down the new king of the hill. And guess what? that one goes next, and then that one, and it cascades down over, and the thread strips from the top down. That's the failure mode, and it's because all the load is on that thread right there, which has nothing above it to stop it from pulling out. That's the problem with trying to put screw threads into soft material. Tougher material, that can handle it by the time you reach the load you want. But when you got soft stuff, that's why it fails. And that's why thread inserts came into being. Now then, here is a thread insert. This is a big fat M12 one. And as you can see, it's like a big spring. This is important. The bits can all move relative to one another. And that is the answer to these threads tearing out. So I'll show you why it's the answer, and then I'll show you how you actually use one of these things. Oops. Here we've got a similar arrangement, but very different. Here there is, I've only drawn half of it. Here there is a thread cut into the native material, as you had over there. But in that thread is these little diamonds, and these diamonds are the cross section of that spring. And how this works is that you drill a hole and you tap it a bit bigger than you want. So this is your thread in here, this is your bolt thread, whatever that may be. So you drill a hole bigger than you want, and then you screw that spring down into the hole, and that's the spring and cross section. And then that provides up the inside of the spring, the thread that you wanted for your bolt. This time when you wind your bolt in, yes, it will pull that spring up against the top thread. But because it can all move, what it does next is it pulls that spring up against the top thread. And then it pulls that one up against the top thread, and that one, and that one, and that one, and that one. And it shares the load all the way down the hole. It's not all 80% on the top thread. It's now shared evenly all the way to the bottom. And that is absolutely transformative when you're trying to put threads into soft stuff. I'll show you how you put these things in. And here is the full helicoil kit. I've used a nice big fat M12 one so you can see everything clearly. That one there is for BA. We used a lot of those on Bluebird, but I've used a big one to demonstrate. So obviously you've got your helicoil. Now an important thing here is that it has a tang on the bottom, and if you look carefully, there's a little nick in it just there. And the reason for this is that you put it in the hole using this device. And that goes in there, and you use that to screw it into the hole. And the tang is what turns it, and that collar sets the height. So if you're doing a lot of these, you set that height, it has a grub screw, and you set the height, and you wind it in until the collar lands, you know it's in perfectly. It's as easy just to do it by hand and check it, but that's what that's for. So that's the thing used to apply the helicoil. You get a drill, which is precisely the right size, which is like no other size because you're not drilling a standard thread, so that's a weird size. And similarly, you get a weird tap. And the thread that cuts is the thread that is on the outside of the helicoil. So once you've drilled a hole, you've tapped it, you wound the helicoil in, you've then got this piece of material down a hole. You then get one of these highly scientific things, and you put it in the hole, and you give it a sharp crack with a hammer, and it snaps the tang off at that point, and then you've got a helicoil you can see all the way through. And I've just found on the bench, there's a one that I was playing with the other day, which has had the tang snapped off, and it's a thread all the way through. So that's a helicoil kit. It's a bit tricky to use. There's other types of helicoils or thread inserts that people will tell you are better. They're not. They're just more foolproof. These are harder to use, but they are without question the best. So having satisfied the cylinder head man that what he actually had was a good job, off he went, quite happy. And I set about devising my putting bolts into chocolate experiment. I mean, it's Christmas, let's have a laugh. So I had to choose some chocolate. Now, I went to the local shop, and all they had in a decent sized bar was Cadbury's Dairy Milk with Biscoff in it, which I think all it did was they cleaned the dust filters at the Biscoff factory, and they mixed it in with some chocolate to a paste and said, there's a new product, and it's grim, it's made of dust. If you like Biscoff, it tastes all right, otherwise it's horrible, and you certainly can't put bolts in it, so forget Biscoff. Then I thought, I'll Google this, what's the hardest chocolate? Which it turns out, and I got this at the local garage, that stuff, 90% cocoa, is very hard, and it is utterly disgusting. You can't eat it, it won't melt, it's like chewing a piece of lino, and it just, ugh. But it's much too hard and brittle. If you're trying to drill it and tap it, it just shatters. It's like trying to put a helicoil into a bathroom tile. Forget that. So that left the usual Cadbury's Dairy Milk, Galaxy. Galaxy's surprisingly good, because if you bite a bit of Galaxy, it has a kind of rubbery compliant texture before it breaks, and that's good for putting threads into. Top tip. But I should have known from the outset what was going to be the chocolate bar for putting bolts into. It was obvious, really, wasn't it? Yorkie, not for girls. At least that's what the advert used to say. Don't blame me for that one. So I got a bunch of Yorkie bars, and I got the tools out, and I devised a means of putting bolts into Yorkie bars. And my plan was to bolt a couple of strips of aluminium top and bottom of the Yorkie bar, get all the bolts in, one Yorkie with just thread in the chocolate, M6 thread, I'm using M6, keep it simple, and the other one with M6 helicoils in the chocolate, and then pull it till it breaks. And to pull it, I put just a bit of steel out from the vise as a bit of a lever arm, and then I put a bucket underneath, put the thing between the arm and the bucket, and poured water into the bucket until it fell apart. At least that's what I thought. It got a bit more complicated and a lot more fun. So here goes with the great chocolate bolt experiment. And by the way, if you like this, I'm still the world's most reluctant YouTuber, but I still do it every week. Don't forget to subscribe so I know it's worth watching. And don't forget to chat in the comments, because that's my favourite bit. You know, you're all my mates on a Friday as far as I'm concerned. My social life is there with you, so thank you. Yeah, anyway, we'll crack on. I'm very much into something I've never done before now, because I have never drilled chocolate with a view to putting a bolt in it. So anything could happen here. Fortunately, Yorkie bars are quite easily purchased. So if it goes wrong, I can just get another one out of the fridge. So here goes nothing. Well, it drills nicely. Chocolate swarf, there's a treat. That should be a thing that engineers can get in their Christmas stocking, shouldn't it? Oh, and it's fractured. Right. That was going so well. And we had a Yorkie failure. Damn, I should be forced to eat that now. That's all right, that doesn't normally happen when you machine stuff. Right, we'll try that again. I think I pushed a bit too hard there. We'll go a bit more gently. I was trying to make sure I didn't go too fast and heat the chocolate, but I'm going to go a little bit more slowly this time. And the chocolate can take its chances a little bit. And then I can eat some more chocolate. I was fat enough to begin with without dreaming this game up. I felt something crack, I'm not sure what that was. I don't think it broke. Oh, it broke somewhere else. Why did it break there? I haven't drilled it there. So, okay, think again. Okay, plan B. Yorkie attrition rates are getting a bit high now. So, plan B. Instead of trying to do it on the drill press, which I think is overloading things a bit, I am going to mark the centres with a centre pop, and I'm going to drill them by hand. That way I can be very gentle and support each individual block. A lot of chocolate swarf this time. And there's that one. Now you'll notice that I've staggered the holes. So I've got 2 on the back, 2 in the front. And yeah, another pile of the most delicious chocolate swarf. Should sell this. Nom. Right. That's how you drill Yorkie bars for helicoiling. Right, I've worked out how to drill the holes. Now we need to work out how to tap them, which shouldn't be difficult. I've done a few experiments. You can tap this by hand, which is really nice. That just goes in there beautifully. Look at that. Ta-da! You can tap chocolate. Not fantastically well. I don't want to go all the way through because I'm just putting short helicoils in. What I don't want to do is
damage the threads at the top. You see that? Just a little thread in there. Yep. It's amazing how well that works, actually. And I know it's a bit of a mad experiment, and you couldn't really put a huge amount of load on a chocolate bar, but it does tap quite nicely. And I've cooled it down. It's been in the fridge, but it's not frozen. It's just so it doesn't, where my fingers touch, so that it doesn't melt at those points. Because what I've discovered is if you freeze it, it goes too brittle. That's the helicoil tap. That's not M6, that's bigger than M6. That's the helicoil tap. So that's tap for helicoil. And I've scratched a little H on the back, which you can just read, which stands for, here we go. And these are the little helicoils. There you go. The tang on the back, diamond section, and you put them on the end of your applicator. That pops through there, and it engages with the tang. And that allows you to just wind the handle, and that screws it down at the hole. You get that top thread there, the last thread, just inside the hole. Otherwise, sometimes when you tighten the bolt in, it'll spring that out. So you make sure that goes down inside, and then you get a little doofer, which you push down the middle, and it breaks the tang away. Okay. Helicoil time. That goes in there. Where am I? There we go. That goes in there. That screws in nicely. Feels good, actually. It's quite grippy. It's not the sort of thing you can put on camera. But that feels like it's getting a nice hold in there. Let's go down a smoot more. Tiny bit more. Half a turn. Stuck. Come out. And there you have one perfectly applied helicoil. Right, only another 4 to go. And there we have one perfectly helicoiled Yorkie bar. How ridiculous is that? Right, back in the fridge, because my fingers are getting sticky. I've not had this much chocolate on my hands since I was 5. These ones, this is my control for my experiment, is getting tapped to M6 by 1. And then I can bolt all this together. This is a bit I'm not looking forward to, breaking the tangs out. But there's nothing for it but give it a push. Yes! Tang broke out beautifully. Yes! See straight through that now. See the tang still in the end one? No tang in that one. Get these two out. Only thing is, what I've done is I've put the broken off tangs amongst the chocolate swarf. So now I can't eat the chocolate swarf. That's a small price to pay. That is the helicoiling complete in that one. Let's see if we can bolt it together. Let's see if this is going to go together. That goes there. Was that started? There we go, that's started. Complete accident, I'm afraid. It's failed. Just when I thought we're going to get a result. So what I'm going to try and do, because that suffered a failure, that just fell off in my hand. I think the chocolate's too hard. Helicoils and the chocolate work very well. It's the chocolate that's the problem. You can see how it works. That just fell off. That is a real shame. Having had a thunk, I've decided that as that helicoil is still intact around 2/3 of its diameter, it still has a fighting chance. So I'm just going to leave it alone. I'm going to nip that up, not very tight. I'm going to nip this one up. That's actually taking a surprising amount of force, that one. I'm going to nip these two. If I don't get any more failures, I'm going to say, right, we're going to go with 3.5 helicoils and we're going to go with 4 bolts. So that's advantage, normal threaded holes before we even start. Now you can actually get a decent nip on those. You wouldn't want to move them too far. Right, so I've got 3.5 helicoils in there. That one, chocolate failed, but it's around 2/3. And we'll see. We'll use that for the experiment. And I'm in two minds. Do I cool this down or do I leave it at room temperature? It seems to be happier at room temperature. I'm going to put it in the fridge for now. But yeah, I'm going to build the other one now. Okay, this is the one without helicoils. This is the chocolate threads. I don't think I want to put the spanner in this, because this is very, that's it down. If I go any further, I can feel it. Ugh. That's all I'm going to get on that. It's how you would imagine chocolate threads to feel. Okay, well in this one, all 4 threads have survived, but they're purely into chocolate. So I've got 4 bolts into chocolate, and I've got 3 3/4, well 3 2/3 bolts into helicoil chocolate. Now I've got to devise an experiment, which the plan was just to put a pull on each end and see how much weight I can get on them before I get some horrific, catastrophic chocolate failure. So I'll go off and devise that next. Now the plan is I'm going to put some water in the buckets and see, I'm hoping, if it fails, it doesn't fall more than, what's it got, 3 inches. So I'm going to gently add some water. Ah! Right. Now the failure there was in the knot that I tied, so I'll fix that. That didn't tell me anything. I knew when I tied that. It's all quite delicate. So I didn't go mad with the knot. Anyway. Oh, that one has started to go. It's at a funny angle. And we have in the bucket, what do we got? What do we got in there? 3 inches of water, if that. I know it's a very rough and ready experiment, but I'm going to set that up again with a little less string and we'll give it another pull and see what it does. Okay, attempt number 3. See what becomes of it this time. I mean, it's doing everything, it's in shear, but it's also got the thing cocked over, so it's pulling outwards as well as straight up and down, so it's kind of the worst of both worlds if you're a bit of chocolate. So, here we go. We're starting to see little failures now. We've got a bit of cracking around the top of there. Yeah, a little bit of a failure going on around the top of there, look. But that again, that's chocolate failure. That isn't so much thread failure. Surely. Hey, whoa! Right, I didn't touch it. It just went up with a bang. Yeah, result, it failed at last. So yeah, let's do a little bit of a post-mortem on that. Let's get it out of the water and we'll do a little bit of a look-see on that one. Right, there is the result. So I've lost the end of the bar, but it's pretty obvious that that's just torn straight through there. That thread is torn out. Not as much of a thread. That one skidded across the floor and I had to retrieve it, but you can see it's got chocolate in the thread. So that one has failed also. The two in the back haven't failed, but the bottom one has achieved a bit of a strange angle. And you can see there's a gap. It started to pull free. That one started to go. But ultimately the failure, I think, has been, I don't know, was it that thread pulled out? Or did that pull out because that block failed? Anyway, we got a failure. This is the most unscientific experiment I have ever conducted in my life. It has no values. It has no nothing. But that is, if we get a ruler, the water is quite scientific, has got, how far is that? 4 inches from the rim of the bucket. So we had to put the helicoiled one in, which is already compromised because we lost a corner of it. And we'll see if we can get the water a bit higher up the bucket before it gives up. Or it might just fail straight away. We're going to find out. Right, let's try the helicoils. Now, anything could happen here, and probably will. Because this is a world first, I think. Helicoiled Yorkie bars. So here we go with some water. I'll try and get it in the middle and go gently. Oh, that's the knots moving. Hang on, I'm ready for this. I've tied better knots. But I've also put layers under so I can remove layers. If the knots move and everything tightens, well, we got to where we were before, and there's no sign of any failure. So I'm going to get some more water. Right, that's about as much water as I can get in there, and that's just touch bottom. But there's no sign of it failing. There is no sign of any failure, and I've run out of bucket, so we're ahead. Wow. Right, back on with the least scientific experiment the world has ever seen. Because I wouldn't fail with the water, I mean, I filled the bucket to the brim. The other one failed when the water was 3 inches from the top. So this time, I'm going to put some steel V-blocks in the bottom, and we'll see what happens next. This ought to deal with a stretchy string all in one go. That just feels colossal. And it's bent that quite a lot. I don't think I'll put another one in, because I think another one might just cause a failure. And somewhere in between 1 and 2 was where it was going to give in. So I'm going to put some spanners in. And it can be the spanner that broke the camel's back. And I can see from here that that's hanging on. Ah! And we spanner check. All that stuff. I think that was a knot moving. So, oh no, we have a failure. We have a chocolate failure. And it's now hanging on a single bolt. That is now hanging on one bolt on here. That one helicoil into the chocolate is now taking all the weight. That is fractured. Ah, yeah. Ha, 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 ha. That wasn't rehearsed. Fractured. Ah, yeah. Ah, ah. Yeah. Complete accident, I'm afraid. Over. Yeah, let's have a little post-mortem on that one once I've had a swift change of underwear. Yikes. Well, there you have it. That is the second failure. And the takeaway from this is not a single bolt has moved. All the failure has been with the chocolate. Even the helicoil that lost its corner, even that one hasn't moved. None of them have budged a millimetre. Yes, the aluminium's distorted. That piece got pulled almost straight. That helicoil is intact. That helicoil is intact despite the thing being bent through 90 degrees. The failure was 100% down to the chocolate, not the bolts or the threads. That one, on the other hand, the chocolate is largely intact, and the failure has been where the thread tore out of the chocolate. So next time somebody comes to me and says, well, you weld an aluminium thing and put a thread in it and I helicoil it, and he goes, oh, you bodged it, I'm going to have a link. There you go.
And there you have it, folks, the great chocolate helicoil experiment. That was a laugh, not very scientific, but there it goes. So if anybody ever tells you a helicoil is a bodge, send them a link to this video. And while you're about it, don't forget to subscribe so you don't miss any more. And we'll get another one in before the Christmas comes. And yeah, Good to see you all. Thanks for watching. Catch up in the comments. See you next week, hopefully. Bye.